So we have data analysts and specialists in AI and machine learning. So
Uh,
my team is doing this.
okay. Okay. So if your team is doing, then I'm presuming that you're already aware of certain things, because otherwise, how are you,
Yes,
guiding the team? Okay.
correct.
So what is the expectation after this course?
Expectation is how to make data more relevant, because uh, we have many data which is coming in, and
Mhm.
also what is the right data to use for predictive analytics, and how to maybe filter out things which are not useful, where to focus
Mhm.
more.
Okay.
Yeah, so these
That
are
that's
some
a
of the
very
things.
specific thing. Okay, that's a very advanced level thing. For example, if you want to know which data is more relevant, etc., you have to do more advanced techniques like principal component analysis, finding out the correlation. So it's a little advanced, but yes, we'll try and see how much we can cover, because this is a very basic course. So that's why I wanted to know that what exactly is the expectation in terms of uh, what to get out of this. Yes, somebody else who can just share your experience, or
Okay.
rather
Good
expectation.
morning. Yeah, maybe
Yeah.
in addition to what Rajesh has mentioned, we are
Mm.
mostly end users. So we give our
Okay.
problem statement to the experts, and we are currently getting the solutions.
No, Rajesh's point of view was, so let me understand this correctly. What I understood from Rajesh was, Rajesh said that he has a team under or working with him who are data scientists. So he is supervising the team, not that he's a customer of the team. These two are very different.
Okay.
If you
Okay.
are, and yeah, I mean, both may be correct. I just wanted to know the perspective. So one is that I am a, let's say, manager in a manufacturing unit, and there is a data science team who provides me inputs. So I'm a customer. The other is
Understood.
that I am heading the data science team. So if I'm heading the data science team, I have to have deep knowledge data science myself. Otherwise, I can't head. So just Rajesh and Vijay, I just wanted to get the perspective that where are you positioned currently? Yeah.
So
Yeah.
as I
Uh,
mentioned, maybe to
yeah.
just clarify a little bit,
Right.
I have a team where we have a basic data analyst
Okay.
with me.
Okay.
So they are able
Okay.
to do all the Python program, and then
Okay.
take out the data from the machines, and then give a solution
Okay.
for predicting the defects and
Okay.
improve the productivity. Yeah.
Right, right. But okay. Let me hear Vijay, and then Prashant, I'll come back to you, and then I'm also trying to understand the structure in our organization in data science. Yes, Vijay. Yeah. So is
Yeah.
it the same like? Yeah. Yeah.
You rightly pointed out. No, it is a different one. Maybe I am an end user, maybe in my
Okay.
division, and we seek
Okay.
solutions from the experts.
Okay.
From this course, what maybe I'm expecting is to see, we have currently data abundantly. We have started utilizing it in smaller bits and pieces of Power BIs and
Mm,
Excels.
mm,
So I want
mm.
to furthermore understand how we can effectively use this data to bring meaningful output
Okay.
for business.
Okay. Just to clarify, Vijay, that Power BI and of course Excel are more like visualization tools. Okay.
Yes.
So we are not covering any visualization topics here. I'm not sure if you had a course on data visualization, which is usually a separate course where Power BI tools like Power BI, Tableau, etc. are taught. So we will not be covering much about this data visualization. But if some of you are interested, probably we can just touch upon a little bit. Okay. So
Okay.
let's see. That is not a part of the course syllabus as such, but if many of you are interested, we can look at it. Okay.
Okay. Thanks.
Prashant. Yes, Prashant.
Yeah, Mr. Ghosh, good morning,
Yeah.
and thanks for introducing yourself. So I am in a leadership role, taking care of business transformation in Bosch,
Okay. Okay.
in our headquarters, doing an enterprise level
Okay.
transformation program.
Okay.
So
Okay.
basically, with this course, I'm expecting to unlock wide range of um, use cases, especially
Okay.
to make strategic decisions,
Mhm.
data-driven decisions, and do
Mhm.
planning based on data, and also
Okay.
think about converting data into valuable questions. So this is what I'm thinking about, and
Okay.
I'm eager to look at your course structure, because we did not get hands-on uh, hands to the course handout. Probably after looking into the course handout, I could probably think about more use cases
Okay.
and
Okay.
application of the knowledge.
So
Yeah.
is the course handout or course structure shared with you?
No,
No, not.
we haven't received
Okay.
it, and I'm
Okay.
expecting that you will show it today
Okay.
to us.
Okay. No, that is a standard course structure that is with BITS Pilani. Okay, so that's BITS Pilani will they have their own process of sharing. Okay,
No,
so
course structure we haven't received it, so we don't know
okay, no, no, I'm
what
saying
we should expect
yeah,
from you.
yeah, no, I mean that will be shared by BITS Pilani. Okay, that will
Okay.
not be directly shared by me. So I'm
Uh,
sure they will do it. I think they probably the last few days they were trying to schedule the sessions. In fact, the final
it was
confirmation
done
also
yesterday.
came to me. Yeah, came to me to yesterday or day before yesterday only. Okay, so I'm sure that they will share that. Okay, but yes, I don't think that will be an issue. Okay. But yes, I think the strategic aspect is very, very important. So we'll definitely cover that. Great. So
Looking forward,
any,
Mr. Ghosh.
yeah, yeah. So any other anybody else wants to make a comment? Think Dinesh or Amit, Akshay, yeah, anybody?
Yeah, so my name is Saurabh Mishra.
Okay.
I'm working as a manufacturing department head for the in the Nasik plant for the
Okay.
nozzles.
Mhm.
Um, so basically, my expectation, like what Rajesh also mentioned, it is about we are also having a lot of data in terms of the manufacturing. We the data is getting generated in terms of the overall, I
Mhm.
will say, tool lives, the overall product characteristics, as well as the financial data. Means one is all from the manufacturing side, second side is also which is coming from the financial side. So in both the areas, how to navigate through data for making the decisions. That is something which I'm looking for, like out of this overall course.
Okay.
So because we like Rajesh, we are also having our teams of data analytics and these things. So
Okay.
how to
So
get a better
from
outcome?
okay, sorry, well, you are from which area? Like Rajesh is talking about manufacturing. Are you also in manufacturing?
Yes, yes, sir. I'm
Oh,
manufacturing, sir.
okay. Okay.
Thank you.
Okay. Good. So anybody else has any other specific thing? Yes.
Jyoti here, sir.
Yes, please.
Just to add, because they have covered most of the things.
Yeah,
So
yeah.
we have overall 55 people on this class, and
Yes.
around 3 to 4% people are in the leadership role, which they spoke. So rest of the people are individual contributors. So
Sure.
so that's what I wanted to highlight you. Most of the things Vijay has covered. So this is how we are looking as individual contributors.
Yeah. No, I understand. I understand that obviously I saw your profile, so there's a wide range, and obviously there'll be little different expectations, and we'll definitely try to cover that. Now, let me share with few things. First of all, uh, a large portion of this course will be hands-on, because I believe that unless you know, and you are all, I think most of you are engineers, and even if you are in senior positions, you would have, I'll assume, grown through the engineering line function. And we as engineers know that unless we do it ourselves, we cannot manage it. Okay. Management can happen at a superficial level only if it is something administrative. Okay, like if I'm a gram panchayat, sarpanch or a district magistrate, I can manage it with common sense. But we are all in technical fields. In technical fields, management comes only after you have deep knowledge in that subject. Okay. Uh, like if I'm in medical line, I have to be a very good doctor to be able to manage it. Okay. So So here also, to enable this process, a significant portion of this course will be hands-on. Okay, so you have to do things on Python, there are other no-code or low-code tools where you have to actually no, run machine learning models, okay, to actually see it. Because without that, it is very superficial. Okay, you just it's like case studies, Harvard case studies, which which have very little use these days. So that's one. The other thing is that because it's hands-on, I would definitely appreciate if you attend the courses live as far as possible. I know that there's a challenge with people who are working professionals. That is, your Saturdays are now fully taken up. I saw your schedule, so it's fully taken up by 4 courses. But try to attend it on live. Reason is that when I show certain things hands-on, of course you will have the recordings later on. But when I show certain things hands-on, if you do it along with me, then certain things, if you get stuck, you can always, clarify in the class. And if you watch the recording later on, honestly speaking, I think all of you will agree that watching later on never happens. Okay, especially with a 2-hour long video, I think it's not practical to watch, for 2 hours. And then if you get stuck with these tools and all, you can't clarify. Probably you have to wait for the next class to clarify. Okay, so it becomes you actually waste more time. So try and attend the classes regularly and try to attend it from your desktop or laptop. Okay, don't attempt it from mobile. The reason is, unlike many other courses, probably you are attending other courses also, unlike many other courses where the hands-on component is very minimal, here the hands-on component will be substantial. 80% of them will be hands-on. Okay, so probably first few sessions will be little theoretical. After that, you have to work on the softwares and the tools, and we'll see many tools. So that's the first thing. So try and attend live. Try and attend from your laptops. Don't attend from the mobile, because in the mobile you will not be able to use this software yourself. Okay. The second thing is, see, most of the use cases that you read, I mean, data science is kind of, if you Google, there'll be many blogs and many books and many videos. It's no big deal learning data science today. Okay, at least at the basic level, you can watch YouTube videos and learn. That's not a big deal. The problem is that most of the examples that you see in the blogs, books are all customer-facing examples. They're all meant for FMCG products or e-commerce kind of business. Okay, you will see enough, or telecom, BFSI, banking. These are the categories of business from which you get most examples. The reason is very simple. These are the industries that adopted digital technologies first. Okay. The digital first companies were banking, e-commerce. These are the companies. Even today, they are the greatest users of digital technology. So most of the examples that you see are from those industries. There are very few examples from your category of industry, which is kind of manufacturing. Okay, so and one of the kind of challenges that you have for learning these kind of courses is you need real data. So I can give you, for example, fictitious data, and you can also get it publicly available data. So obviously, no company is going to share their data. Why would they share their data? So you cannot learn from some other companies. Okay, you can learn only from the data that is available in the public domain. And most of the data that is available in the public domain are related to e-commerce companies or banks or this kind of telecom, this kind of thing. There will be hardly any data related to manufacturing in the public domain. Okay, so I will not be, so if you, the data sets that I'm going to show, okay, they are all, very few will be from your domain. Okay, because there is no such data from your top. So if you want, and I love to do that, if you want something that I can show on your data, see if you can share some of your data with me. Okay, I know it's a difficult thing, it's the NDA issue and all those things. See informally if you can share, see if there's some data which is not so sensitive, maybe mask that data. Because if you share the data with me, of course, you have to give me some time because I have to work on that data myself to figure out that what kind of analysis that can be done. But if you can share your data with me, I can assure you your learning will be more meaningful. Okay, because otherwise I have to share, standard data that is available everywhere, and many of them will not be relevant to you. So you'll come back and say that, you taught me something related to e-commerce customer churn, and what has that to do with Bosch? Which is absolutely right, because there's nothing to do with Bosch. But unfortunately, that's the data that is available in the common domain. Okay, so these are the two very important things that I wanted to share with you. Okay. Any thoughts, questions? I saw a few thumbs up going, so I hope that I can expect some data from you wherever giving the thumbs up. Okay. By the way, yeah, great. Yes, Prashant. Yes, please.
Dr. Ghosh, yes, I think it's a good idea to share the data to make it
Yes,
more
yes,
specific.
yes.
Two observations and comments. Basically, the
Yes.
last conversation, last course in the
Mhm.
foundation of data science, we were able to use Google Colab um,
Yes, yes.
as a platform for doing, let's say,
Right,
coding,
right,
and of course to look into the data
right,
with the Python
right,
program.
right.
If you could also let us know, probably in advance, which other um, no code, low code platform we should be
Yeah, yeah.
accessing.
Sure, sure. In
Then
fact,
we will
that is
look at whether
something.
it is available in our company, because most of us will be using personal laptops or official laptops
Oh,
to
acha,
join
acha,
this
acha. So
course.
some of them may be restricted. Okay, I understand that.
Right,
I understand
right,
that. Okay,
right.
okay. Yes, yes, definitely. I'll give you the names of the platform. Um, and yeah, and of course we'll also be using Google Colab. And by the way, Google Colab is now integrated with. So there are two aspects. Let me also, since you mentioned this, let me also take this opportunity to talk about few strategic shifts in this area. See, obviously, we all knew that coding was difficult. It's known by only few people, and usually as functional managers, especially after a certain level of seniority, we kind of quote unquote was little scared of coding. I'm sure you'll agree with that. Okay, so it is very hard to start as a fresher and understand all the terminologies, how you define a variable, how you define a pointer, and I'm sure if some of you have started it, you would have given up very soon. So, what some companies did was they parameterized certain inputs, and the code was packaged. So that was the birth of no code, low code platform. This was there in the industry, not for data science, for let's say ERP. Okay, so SAP, if you're using SAP is nothing but a no code platform or a low code platform for ERP. Okay, previously everybody used to develop custom developed softwares for their business processes. Then ERP came. SAP process. Same thing happened in data science also. Previously, people were writing everything in Python or R, and then people came up and started making products out of it, so that you don't have to code, and business users can only look at the workflow and do it. Now, interesting thing is, with the advent of generative AI, I'm not sure to what extent you're using generative AI as for your enterprise. Okay, all of us are using generative AI. I'm sure ChatGPT for our personal work, but at an enterprise level, that's a big area that is coming out. An enterprise level, to what extent generative AI is you're using, but that's a different subject. We'll not get into that. So, with the advent of generative AI, you actually don't need to know the code. Okay. So if you have used Colab Notebook, I'm not sure if you used the Gemini integrated with Colab Notebook.
Yes,
So
Gemini integrated with AI.
yeah. So if you use Gemini, all that you actually have to do is know the process and know how to give the right prompts, and rest of the coding will be done. So here also, so once that has happened, actually the no code or low code platforms have become less relevant. Okay, because now if I'm able, no code or low code platforms are, while they are easy to use, they are more time consuming. So if somebody like a who is a efficient coder will never use a no code or low code platform, because you have to do a lot of things. That's for a very small thing, and once you use it, you will learn. Once for a very small thing, you have to do a lot of steps, draw a lot of steps. Okay, so only advantage is that you don't have to know the syntax. Okay, so if you ask a developer, a seasoned developer, they will never touch a no code or low code platform. They will say that whatever I can generate out of one line of code, it requires 3 nodes to do that. Okay, I'll not do that. But with the advent of generative AI and Gemini integrated, actually the utility of no code, low code platform is coming down, because if you now know the prompts that you need to give, anybody can actually generate at least 90% of the. Only maybe 10%, 5% is more difficult, more complex, and that's something probably will go to a seasoned developer. So coming to the no-code, low-code platform, the one that we will use, so we'll use both Colab and low-code, no-code platform. Colab, since you already have, I guess there's no issue. And one that we are going to use is Nime. So I'm just giving you the link for downloading Nime. Second. Okay, so this is the link for downloading Nime. You don't need to do it now. You can download it at your after the session. So this is the tool. Is anybody familiar with Nime, by the way? Yes, no? So I'm assuming that no. So
No,
this
no.
is this. Okay, yeah. So this is one of the no-code platforms that has become very popular. However, they are used more for prototyping. So even the no-code platform that you use, or most of the cases, they are hardly suitable for enterprise-grade application. Okay, because in enterprise-grade application, it's not just about building a model. It is also about deploying a model and running the model, which is a part of ML ops. So there the no-code platforms are not, it's too cumbersome and too complex, okay, to handle. So while we have do have no-code, low-code platforms, they cannot be used for production grade application. Okay, they are used primarily for building prototypes. Okay, so that's the objective. So okay, what is that available in IT services?
No, we have it in-house in our
Oh,
software repository. We can install it.
acha, acha. So you have a, okay. That's the in-house repository. So that is already there. So I'm sure then somebody in the organization might be using it for
Correct.
prototyping. Okay.
You want to install Nime AP 5.33 Business Hub, or only the analytics platform would be sufficient?
Only the analytics platform should.
Okay, great.
Great. Okay, good. So I think that was a preparatory thing. Okay, so let us start with the course. So the first thing that today is again an introductory thing. So we're just trying to recap little things that probably if some of it you might have done. in your earlier session. Let me ask you a very basic question. Like all of you are engineers, and or most of you are engineers, and in engineering we have lots of equations, right? Very simple basic equation we have all learned is, let's say, final v equal to u plus at. Final velocity equal to initial velocity plus acceleration into time, right? Or let's say voltage equal to current into resistance. Now, when I use or a equation for gravitation, when I use v equal to u plus at or ft, is it prediction? Are we predicting velocity? Final velocity based on initial velocity? Yes or no?
Yes.
Technically, yes.
The answer is yes, of course.
Yeah.
So you have given some inputs, which is the initial velocity, which is the acceleration, which is the time, and based on that, you are predicting what will be the final velocity. So similarly, if I hold an object in hand, if I say that what is the time it will take to reach the floor, there's the equation. Based on that, I can calculate what is the time that will require that apple or a ball to reach the floor. So what is, I mean, is predictive analysis same as this, or it is something fundamentally different? If predictive analysis was same as this, then I don't think we need a separate subject or course for this. Okay, because this is something that we have been doing from your class 8, 10. We have been learning equations from simple equations. We are going to more complex equations. When we went to engineering, we got some more equations. Okay, many of you did not understand, but they were equations, and based on that, we are predicting. Is it the same or is it different?
It is not the same. It is
Okay,
different.
so what is
Because
the
variables are too many.
Variables are too many. So that means if I have an equation which has many variables, like let's say I'm launching a spacecraft and there is a lot of variables. Okay, so then I'll consider as a different type of prediction. I mean, when I say too many, then obviously it's difficult to quantify how much is too many.
No, variables too many means there's complex also. That means it is not a straightforward formula which you apply and then predict.
Okay.
So some kind of analysis and some kind of probability and assumptions also required.
Okay. Any other thoughts? Anybody? What is the fundamental difference between, we have been predicting when you say Apple will drop, when Newton says Apple will drop, that's a prediction.
We predict based on probabilities. That is different from making a calculation based on an equation.
We predict based on probabilities. Okay.
Yes.
Why do we need to predict based on probabilities?
Because not everything can be, not every variable can be captured in an equation. The influencing variables, all the variables cannot be captured.
So you are saying that you are saying that I do not know all the variables that will affect.
Yes.
I do not know all the variables that will affect, and hence, whatever limited variables I have, based on that, I am taking an assumption.
Yes.
Am I correct? Okay.
Ghosh,
So,
my thinking
yes.
is prediction is based on past data or historical data,
Right.
to predict future.
Right.
And therefore, in most probability, it is we are predicting based on some amount of recurrence in mind.
Mm-hmm. But then why do we need past data? If we have an equation, established equation,
but
we
the
don't
established
need
equation
past
is coming
data.
from the past data, right? I mean, it is based on an empirical or a scientific
Right,
method.
that I agree. So first time we got v equal to u plus at, or some scientists found out v equal to IR. then he would have conducted a series of experiments that were proven that this particular formula is correct.
Correct.
But having known the formula, I don't need to predict anymore. I will just use the formula to get the voltage or get the current. Am I correct? But that is not the same when I'm trying to, let's say, predict machine's failure. Am I using a formula there to predict machine? There are formulas for, to check whether the machine is going to fail or not. For example, I'm sure if you say that okay, the vibration is, if the vibration is more than this, then
Yeah.
stop the machine.
Absolutely. So if you're calculating mean time before failure, or and that's again based on a previous experience, that if there are parameters going
So
beyond
what is
a
the
certain,
difference? Yeah. So suppose our manual says that if the vibration is beyond or temperature is beyond this, stop the machine because the machine is likely to fail. What is the difference between that and predictive maintenance? Or rather, doing a date, prediction or machine learning. Is it the same as machine learning, that I have a manual which says that, like, we know that if your cholesterol is more than this, you are diabetic, or sugar is more than this, diabetic, cholesterol more than this, you are having some heart problem. Okay, so you already have that, and the doctor says, okay, your sugar is more than this, so you're diabetic and take this medicine. Is it the same as machine learning model saying that somebody is diabetic? You're getting my point. Am I clear?
I'm thinking through. So what
Yeah.
I'm feeling
No,
is
I'm just
that,
trying to see whether my question was clear.
Yeah.
Okay.
So basically, I mean, if you tell that there are parameters in your blood pressure
Right.
or cholesterol is high, there is high chance of heart attack. That probably you can predict
Right.
based on these data, right? I'm
Right.
thinking through that, but probably we'll learn through you in this course what we need to do differently.
Okay. No. I understand. Of course, that's the purpose of asking this question. So let me first make one thing very, very clear.
Jagannath,
Let me just putting a slide up. Just give me a second. The fundamental difference between machine learning, which is one of the foundational pillars of data science, and the examples that we mentioned. Okay. The fundamental difference is that there is something called data-based decision making, and there is something called physics-based decision making. We need to understand this very clearly. So when I am having an equation to predict what is the time the apple will take to fall on the floor, I am doing a physics-based prediction. That means there is a law. The law could have been established through empirical evidence, experiment, but once the law has been established, we know that this is universally true, and we will apply this to data now. Similarly, when we say that if somebody's sugar level is more than so much, the patient is diabetic, there has been experiments that have shown that above certain level of sugar, the person is diabetic. So the doctor will diagnose that person as a diabetic patient. The engineer will diagnose that this machine with this vibration is going to fail. It cannot sustain. By the law of physics, the machine is going to break, and hence stop the machine immediately. This is not machine learning. This is pure physics based. What is then machine learning? Now, as I think one of you rightly mentioned, that it is not possible to know, or even if you know, it is not possible to measure all the input parameters that are going to affect output. A very simple example, while we know the laws of gravity and we find out that how much time a product will, an apple will take to fall on the floor, if we actually calculate the time, it will differ from the time that the equation gives. Why it will differ? It will differ because there is a friction of the air, there is some drift, the surface of the apple may not be smooth, certain surfaces will have higher friction, one side of the surface will have higher friction, other side will have lower friction. All these factors will lead to a situation where the actual time is not the same as what has been calculated. Now, if we knew all these factors and if we could measure them, some of the factors we know, for example, you know that air drift is going to change the time, but we don't, it's very difficult to measure the air drift, or it's very difficult to measure, let's say, the surface irregularities. So even though we know some factors, we are unable to measure them. Okay? And when we are unable, and there will be certain factors we don't even know. So when you are doing this, and we need to take a decision based on where we don't have all the parameters, or we don't know how to measure the parameters, we have to predict based on the parameters which we know. So there are parameters which we know. Let's say we know the height, we know the weight of the ball, etc. And based on that, we are doing a close approximation of what it might happen. But in order to do the close approximation, we cannot rely fully on the equation. So we need a lot of past data which has all these factors which we don't know, and try to find out an output that is closest to the actual output. Okay, so this is the fundamental difference between what we call as physics-based decision making and data-based decision making. Does it make sense, everybody? Yes or no? Yes, all good? Yes or no?
Yes, yes, yes.
Great.
Just
Now,
to
yes,
confirm
please.
the understanding,
Yes.
the difference is mainly the physics based prediction is you have all the parameters known, with that you are predicting, and with the data based decision you are working with the unknown data. That means you have parameters which may influence, and we are not sure of whether all the parameters are valid, and you are going to predict very close to the actual outcome.
But let me again clarify, or take an example. So we know I can apply v equal to e plus ft to get the final velocity of the ball. Okay, but I also know that there are other factors, friction, air, whatever. Okay, which I am not, either I'm unaware of or I'm not able to measure. Okay, if I'm aware of and I'm able to measure it, I probably will derive a formula. How much is the friction? How much is the whatever, lift, etc. That physics can do it. That's what somebody was mentioning, the complex formula. So if I know those factors and if I'm able to measure it, I can derive a complex formula to exactly calculate what will be the velocity. So that will not make my decision database. The assumption is that I do not know all these factors, and probably I can never know all these factors. Or even if I know some of them, I'll not be able to measure it. So I am predicting based on what factors are available. U and FT are available. I am predicting based on that. But at the same time, I know that I cannot apply the formula V equal to E plus FT because there are many other factors. So what I do, I will get F, U, F and T for various data points and see what is the V for each of these data points and try to build a model based on the data that is a that will give a close approximation of what the V would be based on whatever attributes are available. Am I making sense?
Yes. So coming back
Okay.
to what I initially mentioned, that too many variables.
Right.
The understanding is too many variables means there are many variables which may contribute to the outcome of a particular, I would say, situation.
Outcome.
So,
Yes.
you don't know all the variables which may be attributing to this. So
Right.
with the available data, you are trying to predict.
Absolutely. Very, very well. So either you don't know or it's too expensive to measure. Maybe you know there's a air friction, but it's very difficult to measure. Okay.
Okay.
Now, interestingly, this is the data-driven approach is what the human brain works. It's very important to know. Human brain doesn't work on physics-based model. So in our brain, when let's say I throw a ball at you and you catch, is your brain calculating the projectile motion of the ball and finding out what time the ball will reach, and then you're putting your hand there? No. If that was the case, then I think Lionel Messi or Virat Kohli would never have scored a goal or hit a six, because they will be spending time in calculating where they should hit the ball. Okay. But essentially it's physics. But why is it that when, as humans, when we catch a ball, when we hit a six, our brain is our brain calculating the formula? No. Our brain works on data-based approach. That means I have hit the ball many times, I have caught the ball many times. A kid has learned to walk or tried to walk and fell down. And now with multiple times, multiple data points, the brain knows that how to balance, how to catch the ball. Human brain works on a database model, not on physics-based model. And because it works on database model, I'm sure this is something that you have noticed in factories or any of these kind of professions, that there is something called tacit knowledge. In olden days, when there was not much of medical tests available, we have heard about doctors who can just observe the pulse or watch your eyes and diagnose disease. Even in factories today, I'm sure you will see some workers who will just say, "Sir, ye machine ka this the sound of this machine is not good. We need to check if the oil is sufficient or not." And we are surprised that where is this knowledge coming from? So his database mind has over years of experience have captured something, that sound or some vibration, something which he even doesn't know. He can't explain that what made him feel that the machine is going to break down. But that his brain is tuned to that tacit knowledge, because of which he or she is able to say that the machine is going to break down. So human brain works on data-based approach. Human brain doesn't work on physics-based approach. Now, the problem is that obviously it's very difficult to replicate this human brain behavior on database, because A, the availability of the data, okay, and B, the computing power that is required to analyze them. So this concept is not that this concept was known, not known earlier. If you have done your statistics and QT, so today's machine learning, the basic concept, the foundational concept of machine learning evolves from statistics, which was there quite some time. There's no new concept that has come up. Okay. even the generative AI that we are talking about is not something that new that has come up. The fundamental statistical concepts were there much before. It is just that there's not enough data and not enough computing power. That is what happened when something called big data came. Okay. So what essentially changed the entire thing is the idea of big data. And I'm sure this kind of slides you have seen, I've not spent too much time. We are talking about the volume of the data. Is there any cloud platform that you're using in your organization, like let's say
Azure. Azure. we are
Azure?
using.
Very good, very good. Are you working or are you directly involved in some of the work in Azure, like some of your models, etc.? Are you building on Azure?
Some of our colleagues in other functions are doing that.
Okay, great, great. Because since you're using Azure, let's see if we can get some fundamental things in Azure. Some of you are talking about visualization and all. So real-time visualization with from your sensors. Okay, of course we can't have the sensors, but we can have some simulated. Okay, so essentially what has changed is this cloud has allowed you to store a huge volume of data, not only stored but processed as well. And the data is also the variety of the data. Variety means the form of the data. That means previously the data was primarily something in a tabular form, transactional data. So if you're using, so which ERP system do you use? Is it SAP?
SAP.
Yeah.
SAP.
So if you look at SAP, okay, if you look at SAP or any ERP, it is capturing the transactional data of organization. It's called the IT, the information technology, IT. Okay. Transactional system of the organization, sales, purchase, accounts, all these things. But a transactional data is usually very structured, can be put in rows and columns, and also the volume is very low. Even though you may be doing a lot of transactions in your sales, purchase, accounts, etc., but still in today's context, that is very low. Or let's say in the context of the data from coming from the sensors, that is very low. So Boeing has been in the news, so we know that the amount of data that this cockpit recorder, etc., collect, and that needs to be analyzed, that's huge. Okay. Not only that, we have unstructured data. I'm sure you heard about the term structured data and unstructured data, right? Yes, yes or no?
Yes.
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 Yes. So what is the basic difference between structured data and unstructured data?
Structured data comes with tables and tables in the form of
Okay.
tables where we have
Okay.
rows and columns,
Okay.
and unstructured data comes in the form of either it can be audio, it can be an image,
Okay.
or a video.
Okay. Okay. So let's say in Amazon we have images, right? So the images that you see in Amazon for products, are they structured data or unstructured data?
If let's say for the image, if it is converted into of course if it is in a digital form, it will have a for an image, it will have a contrast value that can be considered as a structured data if it is converted to that.
Okay. Compressed value means you're talking about the pixels, is it?
Yes, pixel value, contrast value of the pixels.
Oh, contrast value. Okay, so contrast value. Okay, yeah. Okay, so if it's converted, then it will be structured data. Okay.
Yes.
Okay. Okay. So this is again see if there are two terms I think I must clarify or rather explain to you because this is very commonly misunderstood. Okay. One is structured and unstructured data. The other is big data. Okay. I'll just give you the basic meaning of that. And later on, at one point of time, I probably would spend a little bit of time in kind of explaining the concept, because these are terms that are they float around. Okay, everybody uses it. Okay, but very few understand the real meaning of that. The first is structured data, unstructured data. So when, let's say, some of you, if you know a little bit of idea about database, when I go to Amazon, okay, and I click on an image, what actually happens? Or rather search for a product and I get a product page and get an image of the product. What actually happens? There is a table which says that this is the product ID and this is the location of the image. So image can be in PNG format or JPEG format, whatever. There is a location of the image. So when I click on the product link, it runs a SQL query and it picks up the location of the image, and it goes to that location, picks up the image and puts it there. That's all. So in that sense, the data is a structured data. The image is a structured data. Similarly, when you say, many people say that the reviews, text, they are unstructured data. So when you see the reviews of Amazon, of a product in Amazon, essentially all these reviews and ratings, they are stored in a table. So when it shows the reviews and ratings, it is very much a structured data. When does it become an unstructured data? When, let's say, I upload a particular, let's say, a particular picture of a shoe or this t-shirt, and many apps have that. And I tell the app that, look, I don't want to search. I don't want to search your entire database and find out my shoe. This is a shoe I like. My friend was wearing this, and this is a picture. I'm uploading this image of this shoe. You find out from your database which shoe matches with this picture and show me that shoe, and I may consider buying it. Now what has happened is that the software has to break down the image of the shoe into pixels and match, but that rightly said, the contrast, and find out, use it and find out the shoe that is matching this. So there's something called atomicity of the data in the database. For example, previously the image was one atomic unit. It was not required to be broken down. Somebody wants to see a product, the entire image will be picked up and put. When somebody wants to read the review, entire review will be picked up and put. You don't need to break it. So it will be the image or the text is considered an atomic unit. As long as it is an atomic unit, it will remain a structured data. Moment it has to be considered to be broken down, the atomicity is broken, the same data has to be considered as an unstructured data. So remember, whether the data is structured or unstructured, it depends on the use. There's nothing called some data is universally structured or universally unstructured. It is totally on the use whether we consider the data structured or unstructured. Yeah. Same thing, big data. So we talk about this variety, right? We talked about velocity. That means how fast the data is moving. We talk about the veracity, which is basically the authenticity of the data. There is so much of today, we need to clean the data. We need to, all of these, some people say these are characteristics of big data. That is fine. But what exactly is big data? And what is not big data? Is there some specific size to it? The answer is that big data is that data that cannot be stored or computed through conventional means. So, sometime we'll talk about, not today probably, sometime we'll talk about what is the conventional means of storage and computation of the data, and what is an unconventional. So big data is that data which cannot be stored in a conventional means. That is the definition of big data. Okay. And any data that needs to be broken down further, okay, is not following the atomicity, then in that context becomes unstructured data. Big data can be structured or unstructured. So many people confuse that big data is unstructured data. No. I can have a big data which is structured. For example, Google BigQuery is a tool which is very good at handling structured big data. There can be big data which is unstructured as well. There can be small data. If we take it as the opposite of big data, there can be small data which is structured or unstructured. So the data being structured or unstructured has nothing to do with whether it's big data or not. Okay, so far so good, everybody.
Yes.
Great.
So can we
Yes,
consider a small PDF of 2 MB or 3 MB as a small unstructured data?
As I said, it is a use. So let's say I have, let's say your website may have many PDFs. Okay, how is the PDF stored? Okay, there is a table. In the table, there is a document ID and there is a link to the folder where the PDF is there. And when you go to that page and we click on the download PDF button, what is doing? There's a SQL that is running in the background that will checking the ID number and getting the PDF from the folder and downloading it in your desktop. When you're performing this operation, this is very much a structured data. This particular use where you are going to a website and downloading a PDF document, you are using the PDF document as structured data. There's nothing unstructured about it. However,
Understood, sir. Understood.
Okay.
Yeah, if you have to get the content,
if you have to get the content and analyze it and summarize it, then it becomes unstructured.
Understood. Thank you, sir.
Great. Okay, so we'll talk about more about big data and these days, I mean, management is very good at jargons. Okay, and you can keep on writing papers. There are 4 V's and you add 2 more V's and you publish a paper. Okay, and that's what many people do. So now we're starting with the 4 V's. People have started adding more V's, and you have all of these validity, volatility, visualization. Okay, but okay, fine. At least it gives you a context about what are the properties of big data. But that is not the definition of big data. Big data is something that is fundamentally, has to follow certain methods of storage and compute, which is not conventional. But that I'll take a little more time to explain that. Probably I'll do it in some other session. Okay. Now we all know that these there are 4 this kind or 5 4 now there are 5 actually. There's generative analytics. Okay. So descriptive, diagnostic, predictive, and prescriptive. We all probably know this term. But let me ask you one thing that you are given, let's say, an Excel file with all the sales data, month-wise sales data. Maybe some of your sales guys are doing it. And you kind of draw a chart, and based on the chart, looking at the chart, you figure out that the sales in next month is going to drop. Okay. Will you call that, or what will you call that? Will you call that descriptive, diagnostic, predictive? So you are given an Excel file. Imagine the scenario, which has month-wise sales. Okay, you make a simple chart in Excel, and from the chart, you figure out that the sales are kind of going down, and next month sales is going to be bad.
Predictive.
It's predictive.
Okay. Everybody says the same. No, it is descriptive. Even though you're predicting that tomorrow the sales is going to go, next month sales is going to go down, but it is descriptive because the prediction is coming from you. the the computer or whatever the process that you did, that did not predict anything. That just showed a set of data, maybe in a graphical form. You saw the pattern and your human brain looked at the pattern and figured out that there's a downward trend.
Sir, actually,
Yes.
sorry to disturb. We thought there is an option in the Excel to get the trend line. Maybe if we put the trend line, then it will be predictive, I guess.
If you put the trend line is not forecast, remember, okay? Trend line is just saying a pattern. Forecast is different, okay? Forecast, so trend line is giving you a pattern of the past. So against the trend line also, you have, so it's meant to visually say that, okay, this is going up. It is not predicting. Even a trend line is not predicting. It's the past.
Okay.
Only a forecast will predict. So if you are using a forecasting model, yes, forecasting models are also available in Excel. If you're using a forecasting model, then it is predictive because then the it is a machine learning model which is telling you what is going to happen next or how much will be the sale next.
Is the linear regression considered as predictive?
Linear regression is prediction, absolutely.
Yes.
Linear regression is again the use. If I'm just fitting, if I'm just getting a best fit line, then it's not prediction. But if you're using the best fit line to predict future sales, it is prediction. Clear? Makes sense? Yes or no?
Clear, sir. Clear.
Okay, great. Okay. Now, then my question is that if from the descriptive, I'm able to predict as a human, why do I need predictive analytics? Humans can do everything from the descriptive analytics, should be. I mean, this is a little naive question probably. The answer is very simple, that as long as the trend is very visible, human brain will be able to detect that trend. But many times the trend is very complex, like the stock market trend. Very complex to understand. So there, obviously, you require prediction. There you need the model based on data, not physics. The database model to tell you that where is the stock market going for next few months. Okay. What is diagnostic analytics? Diagnostic analytics tells you the why. So descriptive tells you what is happening. Diagnostic is supposed to tell you why, but it is very difficult to get diagnostic analytics. Most of the diagnostic analytics is still done by humans. Data hardly tells you why. Data only tells you what is happening. And even for predictive also, the why part is human. Okay, that's where humans come in. And finally, prescriptive analytics is typically you can say it's a new name for optimization, where there are multiple trade-offs, and based on the trade-offs, a specific prescription is given. And okay, this is the interval in which you should be maintaining your machine. So that's prescriptive analytics. Now, there's a fifth one that has come in, which is the generative analytics. This is generative AI basically. So till now, the models are not generating anything, not creating anything. They're predicting based on past data. They're not creating any image. They're predicting whether the image is of cat or dog. They're not creating any image. Generative AI, as we all know, is helping to create. So these are the 5 different levels. Okay. So far, fine, everybody?
I was unable to understand
Yes,
the
that's
difference. So why did it happen gives the diagnostic analysis. Predictive gives from the past history and why it happened, I am going to predict the next what will happen. So that is the
The
predictive.
predictive analytics is not telling you why. Predictive analytics, the model is predicting what will be the sales next month.
Correct.
Okay, it
So
is not,
based on the past history
based on the past
and
history, everything is,
why it has happened,
Yes.
that means what is the reason, the root cause. So based on
Right.
that, it will predict the future. That is the predictive analytics.
No,
What
it is
will
not
happen?
giving you the root cause. It is not giving you root cause. Okay, it is seeing the past data and fitting a model and telling you the next month, this month your sales was 100, next month it will be 50. It is not telling you what has gone wrong. Remember, predictive analytics will never tell you what has gone wrong. It is just telling you that this is the pattern of your past data, and based on that, I've analyzed the pattern, fit the baseline, and based on that, I'm saying next month your sales will be 50.
Then what is the difference between descriptive and predictive?
In descriptive, it is not telling you 50. It is giving you the data. You are seeing the data, and you are noticing that maybe if you've drawn a graph, it is coming down, and you are observing that next month it will go down further. It has not told you that it will go down. The model
It's
has
only
not
my
told you
feeling. I am
your my
telling that.
feeling. Yeah, your feeling, and in most of the cases, probably you will not be able to say exactly 50 or 60, but you will be able to say visually that this is going down.
Okay.
Okay, so that's the difference.
So till predictive is fine now. Then
Yes.
prescriptive is. Can you
Prescriptive is
clarify?
optimization. Optimization. Okay, so let's say I want to transfer some product to my warehouse, and there are multiple multiple trade-offs. I have to ensure that the inventory is available. I have to also ensure that the full truckload is achieved, etc. And I create an optimization, okay, which helps me to achieve a certain objective function like minimization of cost. So that is prescriptive. Actually, prescriptive is nothing but a new name of optimization. In many organizations, you have different optimization techniques like transportation, and those kind of typical um, use cases are there for applying optimization. So that is, some people call it prescriptive analytics.
Okay, maybe as an example, if I take a stock market.
Yes.
So, for example, based on the past history, so during the predictive analytics, it will give whether the stock is going to go down to a particular number of points, or it will increase is predictive analytics. Based on this, if it will tell that, okay, you can invest in this particular stock.
Right, very right. Yes,
that will give the prescriptive analysis.
Absolutely right. Absolutely. So that's in fact, there's something called algorithmic trading that does exactly that. Okay.
And okay, the fifth one you mentioned, can you repeat again?
Fifth one is generative analytics or generative AI. Generative AI, which yes, I'm sure you're using in various forms now. So that is where the artificial intelligence is creating something. So till now, all the other methods, okay, descriptive, diagnostic, predictive, or prescriptive, nothing is being created. Whatever has been created, you are just analyzing it. But now you are creating something. Okay? You are creating a content, you are creating an image. So that is generative.
Okay.
And now there is an extension of that, and that is called agentic AI. Agentic AI means that you are not only creating, but you are you are making the models act as humans. So at a very basic level, an agentic AI is something like, let's say, the model predicts that your machine is going to go down. And it requires, rather, the model predicts that the machine requires should be giving should get a maintenance. So if till now it is, let's say, predictive maintenance. Based on this, if it automatically composes a mail identifies the right people who is supposed to be sent the mail. Okay. Then that becomes generative. That you don't need to write a mail or compose a mail. It will understand which machine, what is the type of problem, etc., and create a proper mail. And you may also provide a certain format in which the mail has to be created, and it will create the mail in that format. Generative
That
AI
will be
will stop
generative
there.
AI, no?
That is an example of generative AI in this context.
Okay.
I'm trying to,
Okay.
extend this. And then you can copy paste this, whatever content you have got, and manually you can send the mail. So generative AI, what it has done, it has helped you to create or draft the mail. Okay. But then I say that, look, I don't want to waste the time to send the mail from my mailbox. I want the mail to be automatically sent maybe to the vendor, okay, and to the right person, the vendor, asking the vendor to come and do the maintenance. It should go directly from, once this particular problem is detected. That becomes agentic AI. At a very basic level, there are more advanced level of agentic AI. I'm coming to that. At a very basic level, that's the agentic AI, where the mail is not just composing the mail, but also deciding to whom the mail should be sent and sending the mail. Okay? Clear?
Yes. Maybe I will give an example.
Yes.
So
Sure.
just let me know if that is right or
Yeah,
wrong.
yeah, sure, sure.
The machine,
Sure.
machine itself, for example,
Yes.
based on the machine performance or how the machine is behaving, if the
Right.
operator is feeling that, okay, machine is going to go down, is a descriptive
Right.
analytics.
Okay.
The first level.
Yes,
So the next
yes,
level
that's
would be, he sees that, okay, the temperature of the spindle is going high.
right.
So that is the diagnostic analysis.
Right. Because of that,
So,
the machine is likely to go down. Very right.
go
Yes.
down.
Yes.
So then the third level would be the machine gives an alarm by itself telling that the temperature is going high. So you have to maybe attend,
Stop the line or
stop the
something.
machine.
Yeah.
So that will be the predictive analytics.
Right.
Machine giving alarm and the message at the right time.
Right. Very good.
And prescriptive analysis will be like, okay, the machine in next a couple of hours, the temperature is going to reach to a certain extent. So you please attend and then fill the lubrication oil or whatever is the prescriptive analytics.
Yeah, or maybe let's say there are two options. There may be one is a lubrication oil, the other can be some other quick fix. Okay, or let's say changing a part. Okay, and there is a cost associated with it. So typically that if I change the oil, it will run longer. But if I do a quick fix, it will run shorter. But there is a cost trade-off. That is prescriptive. So it takes all of this and tells you that it's right to do the change in the lube oil.
Okay. So next level generative AI would be the machine itself. From the machine, the sensors will take the feedback and then send the right information through the mail to the right agency to order a particular change part or give information that you have to go and put the oil by itself. That means it is not that you have to go to the machine. So it will go, the message will directly go to the person whom it will be informed.
The message will be drafted. The message will be drafted. So you don't, so the previous case, the operator tells and somebody drafts the message, right?
Correct.
That they're giving the details that this particular part is this machine number and all other details can be there. This is under warranty or not under warranty. And this requires change in lube oil. So somebody has to compose that mail. Okay, refer to multiple documents, see whether this is under warranty, etc., and compose that mail. Here, generative AI already has a knowledge base. What is the warranty period, etc., and it finds out from its own and generates the mail for you. You don't have to do anything; it will generate the mail for you. That is generative AI. And the last step is that shooting the mail to the right person. If it's only generative AI, you just get a copy of that and you just send the mail. But if the mail can be directly shot by the machine itself, that is agentic.
Okay. Thank you.
Very good example,
Raj,
by the way. Yeah.
Rajesh sir, added to your point that predictive analysis in the sense it will not trigger the permanent alarm and it will not stop the machine. Before going to stop, it will give one warning message. Example,
Give
in
one.
your example, warning message, spindle temperature you considered, spindle temperature is around 120 degree maximum temperature. If I say example, around 80 degree, 90 degree, it will give one warning message. Your spindle
Right.
is reached a warning threshold limit, what we call threshold limit. Okay, at that time, we need to predict that in future, definitely it will stop. We are unable to run the machine itself until we take the action for this warning message that we called predictive analysis. I understood.
Okay.
Clear,
Yeah.
na?
Yeah. Thanks, Hemant.
Okay. So, so little bit extension on the agentic AI, but this is a very basic example. Let me extend that further. What agentic AI is actually doing. So, in agentic AI, humans or even machines can be represented by agents. For example, this case where you have replacement of lube oil or anything. Let's say there is a trade-off. There is a trade-off between the cost and the cost of changing the lube oil versus the loss of production. Okay, if I don't attend to the machine, or let us stop the machine, there can be I mean, if I don't attend, probably it will break down, the cost will be huge. Let's say stop the machine. If I stop the machine and let it cool, automatically probably after some time we probably can start it, or maybe we just stop the line. There'll be a loss of production versus if I have to change that machine and replace it with a very expensive part. Now, obviously, there is a cost-benefit analysis. And in the cost-benefit analysis, what happens is that typically there are different stakeholders. There is a production manager who will always, let's say in this particular case, push for changing the machine. There's a finance guy who will say that no, justify the expenditure because next month the demand is low anyway. Why do you need to run a third line? You manage with 2 lines, let 1 line be down. Okay, so there are so many, and then maybe a customer, a marketing guy will say that look, this will delay the customer orders, and this can really have a bad impact on our reputation. So in a normal, typical meeting, what happens? You have this kind of different stakeholders, right? Each of these stakeholders are putting their points of view, and obviously they are discussing and sometimes even fighting, and finally, expectedly, some conclusion is reached. Now, an agentic AI will have the knowledge of this finance guy, of this operations manager, of this marketing manager. That's the knowledge that they'll be fed to, and they will act as agents on behalf of humans. So, as a manager, I am not deciding. The agent on behalf of me is talking and saying that, look, the production has to go on because this has a big impact on the future plan. The finance agent is saying that I don't see any reason because there's so much of cost, the demand is not high now, and keep 1 line shut. This is too expensive machine to be replaced. And the marketing guy is arguing that, marketing agent is arguing that my customers will be dissatisfied, I'll lose some long-term customers, etc. So instead of humans debating, it will be these agents who will be debating. This is the agentic AI that companies are experimenting with. So it's not just about why I made this, because I gave this example is, don't think agentic AI is only about automating mails or things like that. It is actually about replacing the humans in terms of taking managerial decisions. Okay. Any questions, thoughts?
Yes, sir. That manager questions what you said just now. So
Yes.
as per the predictive analysis report, example that spindle case only we will consider as a maintenance point of view. So it will give in future days it is going to fail. You need to replace. How it can be valid and how we can convince this message to our higher authority. Because the cost is coming to picture in this case.
Right,
Blindly we can't change the spindle.
Okay.
So how to validate this data?
Yeah. No. That's a different question. In fact, we'll cover that. It's very, very good question. We will cover. See, it's a very interesting question. What you're asking is, let's say I have predicted that the machine is going to fail and you need to replace a spindle.
Yes.
Actually, so one is how to convince that you should replace it rather than not continuing with the existing machine or stop the line. That is not a data science decision. That's a managerial decision. Okay. What is a data science decision? The data science decision would be, let's say a worker would have anyway predicted, hearing the vibration, etc., would anyway predicted that whether a machine is going to fail or not. Even today, he or she is doing it. But he or she is only 80% accurate. And somebody comes and tells you that why are you depending on this worker who is 80% accurate? I have a very sophisticated model that will be 99.9% accurate. But it will cost you this much. You have to justify to the management that what is the benefit of improving the accuracy from 80% to 99%. How much benefit you will get, how much production uptime you are going to get. Okay, what is the financial implication of that additional production uptime? Vis-a-vis how much cost you are going to incur in deploying that model. That is the decision. But that is not agentic AI, because all these decisions are taken by humans. Agentic AI is where this decision, instead of taken by humans, will be taken by agents who will be trained on human, human-like knowledge. So you are saying that that validation of that predictive analysis data by human only, by human observation, human understanding. Right. Or human and analyzing. Various other logic, absolutely. Various other logic, yes. The human is going to actually take the decision. The agent is going to take the decision, or at least suggest the decision. Yes, sir. Understood. Right. So what I'm going to give, before we actually understand any model or any of these kind of complex things, one thing is very important, is a concept called data-driven mindset. Data-driven mindset essentially means that given a data, okay, forget about any predictive models, given a data, am I able to see some patterns as humans? Am I able to identify certain interesting exceptions in that data? Now, interestingly, and we'll do a small caselet, and let's see what the outcome of the caselet is. Interestingly, it has been observed in many cases, even if everybody sees the same data, everybody does not see the same data, in the sense that everybody is not able to get the same meaning out of it. Same data is given to everybody, but not everybody is getting the same meaning from this data. Okay. So what I'm going to do is I'm going to share with you a very small caselet. Okay. It is not from your industry. It is kind of an e-commerce industry, but in this particular case, it doesn't matter, because it is more to do with how you are looking at the data. And I will also give you a small Excel file. Okay. I'll give you around 15 minutes to go through the caselet. It's a very 2-page caselet. And after you have gone through the caselet, there are 2 questions, very simple 2 questions at the end of the caselet. So you tell me what is what is your interpretation of this, the answers to this the questions that have been given. Okay, so I'm just putting it here. I think I can attach files here. So here, open. Just give me a second. I'm just trying to get the. I've given you the cassette, and also I'm attaching Excel file. You can just take 10 minutes to go through the cassette. Has everybody got the cassette? Yes or no?
Yes, sir.
Great. Okay. So you can just go through the cassette 10 minutes, and then we will discuss the 2 questions at the end of the cassette. Okay, are you all back?
Give me 1 minute.
Okay, sure. No problem. If anybody wants to start, they can. I mean, there are two questions. One question is, so there's a protagonist of the case who has a very accomplished career, has come from a retail business, and she is put into, I mean, she's taking charge as one of the e-commerce ventures, startups, but suddenly things start going wrong. And the case says that the customers are dissatisfied, inventory is going up, the margins are going down. Okay, all sorts of workforce is not happy. All sorts, whatever could go wrong is going wrong. And it's talking about that. What is fundamentally going wrong? Okay. And what should Shweta, the product analyst, do? So first one is obviously descriptive and a diagnostic problem challenge, and the second one is more of a prescriptive challenge. Okay, but we are not using any optimization tool; it's more human driven. So our idea is that given the data in the case, so we have to restrict ourselves to the data and the facts that are given in the case. Okay, there may be various other reasons which we don't know. So we don't know because they are not mentioned in the case. So we'll try to draw our conclusion based on whatever information is available with us. And the information that is available with us, apart from the context, is the Excel sheet, which gives me the day-wise number of orders booked from January to March. So that's the data, hard data, only hard data that we have. And based on that, we have to answer these questions. Okay. So over to you, your views and comments.
Looking at the data, we can see that it is kind of cyclical in nature, weekly.
Okay. Okay. The weekly cyclicity, yes, that's right. So what does it tell us about the problem, or does it have any relationship with the problem?
Yeah, there are two relationships. One, Shweta was in her earlier experience, she was able to crack this cyclic.
Right.
Each day. That she is unable to replicate here.
Yeah.
And
so along with cyclical,
yeah.
This weekly sells every 7th day that high. So maybe Saturday, Sunday, they get more orders.
Okay.
And also the veracity of data is high in her second role. There she can think about to bring in more focused analytics.
No. I mean, of course, she can do a lot of things, but our objective is just to figure out that what, given the data, are we able to diagnose what might be going on, given the data that we have. Okay, of course, more sophisticated analysis can be done. I think it was right, Amit Kumar, right? You mentioned that every 7 days is changed. Did you check? Somebody has checked from the calendar that during the times, if you
Mid
I
of
think
the
the
week.
date,
Mid of the week, it is increasing.
middle of the week, okay, and weekends.
Weekends, it's going down actually. The orders
So
are going down.
Okay, so let's quickly, those of you who have not drawn the Excel chart, let's do that, and then let us try and see what information or what diagnosis we can do. So this is our data point. We can simply do a line chart. Enough. Yes. And this is what it shows. So it shows a pattern, and if you look at the calendar during this time, 22, if January 22 to March 22. By the way, this is real data. Okay, this is not a fictitious data. It is a real data of an e-commerce company. Of course, I can't reveal the name of the company, but it is a real data, and it's a very, very common phenomenon in e-commerce business. Very interesting that in e-commerce business, it is seen that the number of orders in the weekends are less, whereas the number of orders in the middle of the week is very high. Probably the reason is that during weekends, people anyway go out, and when they go out, they prefer to shop in the retail stores, because if I'm going out for a movie, I'll rather do my grocery in the supermarket that is present in the same shopping complex rather than order online. Okay. On the other hand, in the weekdays when I'm busy, I'll probably order online. Okay. So it's a very, very common trend across all e-commerce businesses that in the middle of the week, the number of orders booked is high, whereas in the weekends, the number of orders booked is less. Now tell me what is, what has that to do with the problem that Shweta is facing?
I think handling inventory is a main concern here because of the fluctuation of the orders, what is there. So sometimes the stock is going out, and sometimes the stock is 300% of what of the actual value of the order. So that is the data what is available.
Yeah, but is the fluctuation predictable? Shweta should have found that out. Yeah, Shweta should have found that out. Then why is she not able to do that?
Shweta experiences in the previous the weekend was high. The demand was high, but here the pattern has changed. It has shifted to mid of the week.
Yes.
If she is operating with the same kind of a mindset, then this is maybe creating inventory handling issues, operational issues everywhere, and it is leading to customer dissatisfaction and this cash flows, everything. This operating margin issues. Yeah.
Yes, absolutely. So the fundamental problem is that presumably, though it is not written specifically in the case, presumably Shweta did not look at this pattern. Because she came from a mindset of traditional retail where weekends were very, the footfalls were very high, sales were very high, and probably she thought that is the same pattern that is going to continue in the e-commerce space. Okay. but it is actually the reverse. And that probably took Shweta off guard. So Shweta would have planned for more resources in the weekends. Uh, mm, mm, as a result, the inventory would have shot up in the weekends. But there are people who are lying unutilized, which might have resources, other resources, which might have increased the cost. On the other, in the middle of the week, Shweta was having less inventory. So orders not to be serviced, orders were getting cancelled. She probably had less resources to handle the orders and deliver it to the customer's place. So the people were stretched, the orders were getting delayed, the workforce was stretched, there was bad relationship with the vendors, and all sorts of problems were coming. Okay. So now the next question is let's say we find out the problem, Shweta has found out the problem. What would be the solution? What should Shweta do? So there is a seasonality which is undeniable. That's the way customers shop, and you can't do much about it. So what to do now? What should Shweta do?
First of all, she has to do data-driven demand forecasting.
Is forecasting an issue? I mean, forecasting. The demand is not changing much. If you see, the demand is pretty flat.
No, I'm talking about the days. Earlier it was weekends. Now it has shifted to mid. Now she has to see the pattern and forecast the demands for the weekday, all the days, 1 to 7.
I think now that you know that there is the peak in the Wednesdays and Thursdays, and if you look at the demand is pretty stable. It is flat. It's not that it's changing very erratically. So it is pretty easy to understand what the demand would be in each of these cases. And but the question is, knowing the demand, what like? In other words, let me just draw this. So I know this. I know that. Yeah.
Then she has to work on inventory optimization, delivery efficiencies, employee engagement, such kind of topics where she take care of all the margins and all. Yeah, inefficiencies she has to remove. Yeah.
Okay, so we are seeing that there is a demand like cycle, right? So you use something like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and again Monday. Like this, right? Now, so this is the number of orders, which is the indicative of demand. Now, let me put this question that, let's say, I have two companies, this is a hypothetical question. Let's say there are two companies in the same industry. More or less everything is same. And one company that somehow the orders are in this pattern, and another company, the order is, number of orders is more or less flat. Let's say this is company B and this is company A. Which company do you think will perform better in the long run? Company A or company?
Company B.
Company B. Why?
Because they have a steady linear trend instead of this wave trend.
Yes. So what is the advantage if the line is more or less linear, or the number of orders is more or less flat compared to it
Because
is
they know.
changing? Yes.
Yeah, because they know exactly the customer withdrawal pattern, and thereby they are maintaining the inventories exactly the same.
No, I can also in the black, the A company also knows the customer pattern.
So it's
It is
stability in
not. It is not
operation.
uncertain. Okay, understand the thing. Just because there's a variation doesn't mean it's uncertain. I know that every Wednesday the order will be more. That is not uncertainty.
So company B
Okay.
has got a better stability in terms of how much inventory to be maintained at a consistent level, and the production can also be uniform.
Okay. 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 So let's generalize this a little bit. For every servicing every order, there is a set of resources that are required which incur certain cost. Now, ideally, if my demand is varying, and I know that the variation of demand, not that I know the variation, it's not that it's unknown to me. I would like to vary my resources in line with the variation of the demand. Inventory, my workforce, my factory, lines, everything I should be able to ramp up and ramp down according to the demand. Because that will always ensure that I have a fixed margin. If I am not able to do that, if my actual resources is flat, but my demand is varying, what is going to happen is there will be certain points where I will have, I will have some constraints, okay, for which I will not be able to service my demand. So I'll be able to, I'll be under servicing my demand. On the other hand, there'll be cases where I will have excess capacity, and because of which I will have unabsorbed cost. So on one hand, sometimes I will have under service and not be able to service all my customers. I may have to cancel orders, and in some other cases, I will have unabsorbed cost. So either way, in the long run, my revenue as well as profitability is going to be hit. So ideally, I would like to move to this dotted line of resource. But the problem is that it is very difficult to vary my resources in this short cycle. For example, I cannot say that, okay, there I will recruit 100% or 50% of my workforce who will work only on Wednesdays and Thursdays, because those are the two peak time. Because they will say that, what we do for the rest of the days. You are telling me that we will come and work only in 2 days. So what will do in next of the time? So you say that, okay, I'll subcontract. Now subcontractor also says that your demand is so much varying. You are asking for people only for 2 days. I'll charge a huge amount for that because I don't know because the rest of the days what I'll do with this workforce. So it is very, very difficult to vary your resources according to your demand. So what is the option that you have? The option that you have is try and see if A can move towards B. In other words, which means that I am flattening the demand curve. Flattening the demand curve. How can I flatten the demand curve? I flatten the demand curve by providing certain incentives to my customers to buy more during the lean period and buy less during the peak period. In other words, I have to encourage some of my customers who typically buy during the peak period, buy during the lean period. How do I do that? The very common thing is something called surge pricing, which is there in every industry today. and the other one is deep discounting. In the lean period, you provide deep discounts, and in the peak period, you increase your price, but you cannot increase your price too much, because if you increase your price too much, your customers may go to your competitors. So you have to increase your price only by that much, where the customer does not go away to your competitor, but at the same time, the customer is encouraged to buy some of them, not those who need the product urgently, but those who can afford to wait, you are encouraging them to buy during the lean. In every industry, in some form or the other, there is surge pricing and deep discount. For example, restaurant industry, you have this happy hour. So what you essentially need to do here, yes.
Yeah, this
Yes,
will
sir.
be predominantly in B2C.
It is predominantly in
kind of-
B2C. That's why it is I said that this is not something which is typically related to your industry, but it is a demonstration of how a data-driven mindset should work. That means when I see the data, I should be able to recognize the pattern. Okay. So far clear, everybody? Yes.
Yes.
Great. So I think we are over time today, so we have to close. You will have another class now after some time.
10:30.
Oh,
10:30.
10:30. Okay. So I think I'll not hold you back because we have to take a small break. So I'll then see you next week sometime. Okay. Bye everybody. Bye. See
Thank
you.
you very much. Good
And
night.
I
Thank you, sir.
think
Bye.
there are two campus
Sir, can you,
components. Yes.
sir, can you refer some books which we can use?
I'll refer some. So, okay. I thought it's there. Anyway, it should be there in your course outline also, but I'll check that
Normally,
and refer.
course handout was shared
Yes.
by the professor himself during the first session.
Oh.
To
Previously,
understand,
is it?
yeah.
Oh,
So maybe
So I'll check that once. Okay, if that's required, I'll share the course structure, and also I'll refer the books.
Yeah.
And by the
And,
way, I think we there are two campus components, right?
Exactly. Before
Yes.
EC2 and EC3.
Yes. Hopefully we'll meet you there. So it's for 1 day or 2 day for every course, or it's
1 day for 2
okay,
hours.
for 2 hours. Okay, fine. So
Yeah. Could
great.
you
So
also share the slides in our Teams
yeah,
channel
all
and
the
also
slides, all the slides I'll share definitely.
and
However,
also
when
the
we are
image which
doing,
you drew, if you could
yes,
share,
yes.
that would be
I
interesting.
yeah. Only thing is that the hands-on activities that we'll be doing, obviously, you cannot have any PPTs for that. So for
Right.
those, you need to refer to the videos, okay? Because those are activities that we'll be doing on the software, okay? Okay, great. Okay, thank you. See
Okay,
you
thank
then
you,
next
sir.
week. Bye.
Thank
Thank
you.
you, sir.
thank you.
Thank you.
Thank you, sir.
Good.